All right, this is the second FRQ on the 2019 AB exam. So we can use our calculator if we need to. First question, so we have the chart is in terms of time and velocity. And it says justify why there must be at least one time on the interval from 0.3 to 2.8 where the derivative of velocity, the acceleration, is 0. And so what I looked for is just to see what I could see on the table from 0.3 to 2.8. And they're talking about the rate of change must be 0. So this is like a mean value theorem problem. Since they said that the rate of change equals 0, it's not just mean value theorem, it's Rolle's theorem, if you'd like to use it that way. So I did notice that these had the same y coordinate. So before you can even use one of those theorems, you do have to say that since the table is differentiable, it's continuous. So since this is differentiable, it's continuous on 0.3, 2.8. And then after that, I went ahead and said that this is 55 and this is 55. And since they're the same value, then we can say by Rolle's theorem, there exists some C on the interval such that the derivative is 0. Or your other option is you could say that, I'll show you, you could do your rate of change, the velocity at 2.8 minus the velocity at 0.3 divided by 2.8 minus 0.3. So I'm doing my slope here, show that the slope equals 0, and then you can say the mean value theorem. So either one of those is fine. All right, part B. Use the trapezoidal sum with 3 subintervals to approximate the value from 0 to 2.8. So I said 0 to 2.8, Vp of t dt is, I've got 1/2. The width of the trapezoid from 0 to 0.3 is just 0.3. And then the heights there would be 0 plus 55. And then 1/2, the width is from 0.3 to 1.7 is a width of 1/4. And then you've got 55 plus negative 29. 1/2. I've got a width from 1.7 to 2.8. That's a width of 1.1. The heights there, negative 29 and positive 55. So I typed that all into my calculator and I got 40.75. All right, part C, we have a second particle. They gave us an equation. So what I'm going to go ahead and do is plug that equation into my calculator. And then they said the window is from 0 to 4. They said when it's at least 60 meters per hour, so I know I need to go above 60, maybe to 70. There were enough clues in there that I didn't really need to find my own window. It's pretty good. Okay, so we want to know when that is greater than 60, so I'm going to put that horizontal line at 60 in there. Okay. And it's greater than 60 from here to here. So I'm going to go ahead and say VQ of t equals 60 at, and then I'm going to figure out what those two values are. So I'm going to find the intersection, 1.866. And before I move on, I'm going to go ahead and quit to get out of that. I'm going to hit the X button because that takes that whole decimal. And I'm going to store that as a variable. It doesn't matter which one. So I'll go ahead and write down I stored that as A. And then there was another value where it was 60. So number 5, go ahead and scroll over to that other intersection. 3.519. And then I'm going to do the same thing. I'm going to store it as B. Okay, so now it says we want to find that distance traveled, and they tell you that total distance traveled. Sorry, I had to make sure I was on the right problem. So I'm going to look at the interval from A to B. Since it says total distance traveled and not displacement, that means I need to do the absolute value of this. So Math 9, from A to B, get the absolute value in there. Function that I programmed in for y1, 106.109. Okay. All right, for part D, they want you to find the distance between the particles. So they say a particle Q that at time of 0, it starts at -90. And then to compare the particles at a time of 2.8, then I need to see where Q is. So I'm going to say -90 and then 0 to 2.8 and see what that is. So 45.938. And then particle P, this is the answer from part B. So I'm going to take that, I'm going to subtract off 40.75. Was it 40? Yeah, it was 40.75. And I get 5.188 as the distance between the two particles at that moment in time.